Hello, everyone. Welcome to this L'Allemand Animal Nutrition webinar session. And today I will be really happy to spend this period together, focusing on this dedicated session on the protein. Okay, so how to adapt swine formulation, speaking about the protein strategy. So this protein topics is one of important, especially nowadays. Protein strategy is totally fully related to performance of animal. Especially nowadays, it's related to the cost of the feeding with such a high protein market, so sensitive. Also with the high topics and the hot topics of health consideration, direct relation with protein strategy, also related to antibiotic resistance. And something which is growing everywhere is a relation to environment, with also the capacity of the animal to retain this protein, and doing so to protect air and water. A lot of work has been done on the protein strategy, and new approaches have emerged. We have more and more global approach, looking and helping us to approach more accuracy. And we have specific concepts showing the impact on the macronutrition, but also on the physionutrition on those proteins. Then we are able to change, to modify the usage, the best usage of ingested protein in order to cover all the specific physiological requirements. So today we're gonna go through many topics in this half an hour session, from the classical description, the valorization of the protein in swine, look at the main limit for the digestibility of those proteins, look what are the main properties on the swine physiology, how this protein content is related to the gut microbiota, and we will finish on the specificity on the piglet. The crude protein description is very classical one. When we are speaking about crude protein, we are not really accurate, as we are using a kind of estimation using the nitrogen content multiplied by a standard coefficient. And this coefficient used for nutrition, for swine nutrition, is the one referring to casein, 6.25. In the lab, all over the world, we are using mostly two different analyses, the Keshedal one and the Dumas one. Two of them are quite accurate, not perfect accuracy, but it's accurate enough. And we are facing some analytic tolerance, making the accuracy from 2.5 to 6% in between the result of this analysis. So when it comes to crude protein, the concept is not that accurate, and we have to deal with. More and more fast analysis is done thanks to the NIRS, near infrared spectrometry, helping in the factory to have a fast, let's say, a fast knowledge about the crude protein content, in order to be able to make some segregation, to have more accuracy in the matrix description. Protein, it's also a big family. We have inside this global description of protein different parts. We have the true protein, which is an amino acid succession with a spatial organization and concentrated in globulins and albumins. We have peptides that are small polymer of amino acid, less than 50 together. We have free amino acid, and totally we know 21 of those free amino acid. We also have one fraction which is a non-proteic nitrogen, including urea, nitrate, amines, ammoniac, and we have everything related to the genetic material, known as nucleic acid. In the pig, what is ingested as a protein will be partly digested, and coming from this, let's say, what will happen inside our pig, we will have one fraction that will be retained, and this retention part will be very useful and important to cover maintenance and production requirement. And we will have a part, and a big part, that could be excreted, and then we will find it back in the feces and in the urine. And it is this one that we are looking to control and to limit in order to express a better retention inside of our pig. When we look to a, let's say, average picture of what is happening to the nitrogen inside a pig, we can be surprised of the global level of nitrogen that can be excreted in the environment outside of the animal. So when we have our total nitrogen from our animal in average, we will have one fraction that will be digestible and another one that will be considered as non-digestible. We can say resistant. Those resistant nitrogen will be used by the population of bacteria inside the animal, and a big part and almost all will be found back directly in the feces. On the other hand, the digestible will be processed, will be absorbed, processed in the animal. One part will be non-directly used, one part will be used depending on the physiological stage, one part will be used for maintenance and growth. And coming from this digestible fraction, we will find back a quite high level of nitrogen in the urine. So the global efficiency of protein is, for a pig, not that high. There is no protein digestion without a big importance of enzymatic process. Most, I will not say all, but most of the protein sources need to be processed and digested thanks to an enzymatic process in order to be absorbed in the animal. So what's happening in the stomach as a protein denaturation is key, is very important. Our protein need to go through a low pH to be able to activate a pepsin process that already raised the problem of immature piglet that don't have such a low pH in the stomach. That also open the question of the stomach retention times that will directly affect the quality of this protein preparation. When it's done, in the duodenum, we will have some pancreatic enzyme, specific, like always with enzyme, that will be able to do the process in the lumen, and that we also have some intestinal wall enzymes that will do the job directly in the cells. In the jejunum, we will also have the capacity for a classical absorption of amino acid, but also a capacity to absorb some dipeptide, mostly dipeptide. In the large intestine, what has not been absorbed in the small intestine will be used by bacteria, most of the time specific bacteria, opportunistic, mostly aerobic, that will be able to use those resistant protein or not digested protein in order to produce some byproduct like branch-chain short fatty acid, amine, scatol, ammoniac, all those components that we are not looking for. If we check in the lumen of our pig, protein is not only coming from the diet. We have amino acid coming from classically from the feed that will be partly digested in the small intestine after the stomach process. Part of it could be let's say, fermented by bacteria inside the lumen. But we also have some excretion coming from the animal itself. That can be, for example, the bile acid. That can be any kind of excretion coming from the animal to the lumen. That can also be the mucin. That can also be some dead cells. So we have two sources of protein or amino acid that can be found inside the intestinal lumen, the one coming from the diet and the one coming from the animal production. So endogenous and coming from the diet. The main component of those protein are amino acid. Those amino acid, inside this family of amino acid, we have essential, so-called essential amino acid. Those ones are not synthesized by the animal. That means we must, in the diet, cover the requirement in those essential amino acids. And the efficiency of those specific components come from a balanced composition, a relative composition. We also have so-called semi-essential amino acid, usually classified as non-essential amino acid, that we know that in certain physiological period or stage, those can be considered as limiting factors, and we are more and more improving our knowledge on those let's say semi-essential amino acid, and we are improving the way of using them. For essential amino acid, if you look to a ratio between essential amino acid to total amino acid provided in the diet, as soon as you improve this ratio, you will first improve the yield of nitrogen utilization. So it's positive until you reach an optimal value, which is roughly around 60 to 65% of total amino acid, and then it will become detrimental. It will become negative. The essential amino acid you will provide at a higher level will not lead to a better yield of nitrogen utilization. So again, the way we are calculated, the way we are providing the amino acid balance, it's something important in order to face the optimal yield of utilization. And that's the reason why the ideal protein concept has been developed. And it's a very strong concept, very robust concept. In this concept, amino acids are, let's say, described in a relative composition. That means that we are able to express what should be the global content for the main essential amino acid, usually mostly 6, but more and more we are taking into account 8, 9 amino acid in order to have the right balance between them to avoid wastes, but also to avoid lacks. That's an example of composition. Relatively to the digestible lysine content, we may calculate, for example, 61% of sulfur amino acid, methionine and cysteine, or 30% of methionine in the ratio methionine to digestible lysine, 65 for the digestible threonine, 21 for the digestible tryptophan, and so on. Usually, we are doing this for 6 main essential amino acid, and I told you more and more, especially for piglets, we are looking for 8 to 9 amino acids. The lower we want to drive the crude protein level of the total diet, the deeper we need to go in this amino acid description. Again, it's a very robust concept. When it comes to your matrix, We also have several levels of accuracy. Usually amino acids are described in disponible amino acid. We use for a quite long time digestible amino acid, which is already a very accurate step. And we are not using almost at all, let's say, the total amino acid expression. In those different steps of accuracy, we are expressing what is the total content of amino acid, which is the first level. That means something, but not directly for the animal. The second level is a digestible amino acid that take into account the first step of specific endogenous losses coming from the animal. And the last and more accurate step is when you take into account basal endogenous losses. So in the matrix, we are able to take into account the impact of the feed, but also the impact of the animal physiological stage. As we already discussed, digestibility of protein is very important. So we have some, let's say, criteria that helps to improve this digestibility. That can be avoiding the anti-nutritional factors. That can be trying to avoid too high level of heat treatment. One process which is really important, directly related to the digestibility, is the particle size. We have this kind of relation that you have on the screen, showing that the smallest particle size, the better the digestibility of your raw material. There is a direct link between the particle size. Small particle size will help to release a higher level of digestibility of your raw material. So coming to the protein strategy, that's why we are pushing for a small particle size, especially on proteic sources for piglets. That's one way, first, to improve global digestibility, but also to play on what is becoming more and more important. I mean, the kinetic of absorption. Let's say 10 years ago, this concept of kinetic of absorption was not taken into account. Today, especially again for piglets, this is one, let's say, criteria to take into account. I don't know any matrix description today to express this capacity of this ability coming from one type of protein source to have a fast or slow digestibility. But we have classification of raw material that can help to have a range on the, let's say, in the choice, in the global strategy you will have. This classification may help you to have the nice range in order to have the perfect, let's say, release of amino acid depending on time. When it comes to kinetic of absorption, it helps to create more specific property, we should say functionality, coming from the protein. It may help to have a better gut mucosa valorization. It may also help to change the, let's say, epithelium absorption capacity, not only for protein, but also for example, for glucose, modifying this absorption. And it can, on the top, and we will have some word later on, also impact the behavior of the animal, playing on the umami. We have several methods, mostly in vitro, expressing this difference in the speed in this digestibility. Boisson method is one of them, quite accurate, and it shows clearly that from the same digestibility, we may have big differences between the time it will be absorbed from one raw material to another one. And we may distinguish, for example, fast digestibility below 1 hour. So exactly for, you will find for synthetic amino acid or yellow procedure in animal nutrition. Fast absorption, which is in between 1 to 3 hours. Slow, which is classically seen with a soybean meal, between 3 hours and 1 day, and resistant with no absorption. This criteria of kinetic of absorption is a real help for the piglet diet securization and increasing functionality. Classical raw material like whey concentrate, blood plasma, very specific hydrolyzed yeast, that of course synthetic amino acid, show this flash digestibility. And this flash digestibility help after one meal to have a peak of absorption with a nice combination of amino acid that will create the efficiency of this absorption. And we have some examples, some nice examples showing that, for example, as soon as you improve the digestibility in this kinetic, it will also influence the average daily gain. Another impact, and I will be fast, but we may spend more time on this composition, is related to the requirement, the known requirement on amino acid. Here you have on the screen an example expressed for fatteners, showing that depending on the, let's say, whether the farm is under a high sanitary pressure or a low sanitary pressure, the capacity to retain protein when you use the same diet will not be the same. And depending on your amino acid concentration, the retained protein will still different as soon as you have high pressure. What does it mean? Your amino acid will be diverted, kind of waste, in order to face this immune challenge. Okay, what does it mean at the end? The global requirement for amino acid also depend on the immune status of the farm. If we spend some time focusing a bit on piglet specificities towards protein valorization. For piglets, something very interesting is to make a specific description, not only focusing on the crude protein, but being able, especially in your matrix description, to have a segmentation of this crude protein. In reality, what is happening in a piglet? You have your crude protein composition coming from many, let's say, a source of protein, and your piglet will face one digestible fraction. This one is potentially usable by the piglet in order to face, again, maintenance and production requirements. We have a non-digestible fraction. This fraction will not be able to be valorized by the piglet. Okay, and especially with piglet, in between we have the digestible but non-digested fraction. This one we are not really able to estimate what it is, but pathogen, they will be able to use this non-digested fraction. Okay, so the non-digestible fraction is always a fraction for proteolytic fermentation, what we are not looking for. We need to control. The non-digested fraction is also potentially a substrate for proteolytic fermentation. So we need also to take care and to control this fraction. And the valorized, the digestible fraction is the one that is expressing what is the potential usable content of amino acid that will be potentially helping the piglet for growth and maintenance. every raw material can be described between total crude protein and this non-digestible protein fraction. And it's quite interesting in your strategy, and I should say, especially in order to control the cost, but also the health impact of your feed. As soon as you are able to put a number of this non-digestible protein, you may adapt your strategy. It's impossible to look for zero non-digestible protein, but as soon as you are able to control, you will maybe prefer to have 2.5% of this non-digestible protein instead of 3%, just to avoid diarrhea. It's important also to say that this non-digestible protein fraction is also hiding very different property or capacity, depending on this quality of non-digestible protein. Some resistant protein could be processed almost in the end of the small intestine. Some of others could be processed by proteolytic bacteria in the large intestine, at the end of the large intestine, creating differences in the quality of metabolite, but also in the impact, speaking about inflammation, speaking about also the change in the population. So all those non-digestible protein doesn't have the same impact. To avoid the non-digested protein fraction, we really need to focus on what is happening inside this small stomach. Okay, this pH in the stomach is something very important. So it's age depending. We are facing more and more immature piglets. Okay, immature piglets are showing more irregularity in this gastric pH. From the suckling piglets, with mostly the acidification is coming from the lactose fermentation, so the very low impact on the gastric pH. And then when it comes to the weaning, we still have a lack in this capacity to have a low stomach pH. And if you add an irregular retention time inside the stomach, you have two components to create non-digested protein, because the necessary denaturation of the protein that must happen in the stomach will not appear. In this case, you may pay for expensive protein quality, and you will not be paid back because this expensive protein you choose will not be processed, and then maybe will be used by some proteolytic pathogen bacteria that will produce negative metabolite that will create disorder later on. This pH in the stomach is something important. Again, you have on the slide what is on the screen, the classical evolution of the pH of the animal. And you see in red what is the optimal pH zone area for the optimal pepsin activity. And you see here that it should be around 3 to 3.5 in the pH. Usually for piglets, we are around 5, from 4 to 5, which is not at all the optimal, let's say, area for this pepsinogen. I come back to the kinetic of absorption. As soon as you are able to use, let's say, free amino acid. So we know synthetic amino acid with the limit they also are bringing, but classical natural free amino acid will be absorbed without requiring this pepsinogen transformation, creating, even in an immature animal, the capacity to absorb this protein. Another way, and usually we try to accumulate it, is to have a look and to control the acid binding capacity. Okay, So many components are acting on this acid binding capacity, mostly calcium, mostly protein content. And as soon as we are able to control it, we are able to have an active modification of the pH of the stomach using strong acidifier with a low pKa. Okay, what is happening with as soon as we have a non-digestible protein or non-digested protein, we have a flow of opportunistic bacteria, most of the time aerobic bacteria, that will very fastly be able to use those material in order to use it as a substrate to produce, to develop, to multiply, and to produce some specific metabolite that the animal will have difficulty to get rid of. We will have a cost for the clearance of those, let's say, components. So it's first waste of protein, and at the same time, it's a cost to control. So this fermentation of protein will depend first on the level of the crude protein in the diet. And you remember, inside this crude protein, the level of non-digestible protein will be directly influencing the fermentation of the protein. So-called here the digestibility. We will have the stomach efficiency, retention time, pH. The level of stresses is also another way to have a very active proteolytic bacteria, again, mostly aerobic bacteria. But we also have some other interaction with some other component like fiber, fermentable fiber, or on the opposite, anti-nutritional factors. Okay. Those are totally modifying the fermentation of the protein. A lot of those proteolytic bacteria are also known as pathogens, meaning that those bacteria are also producing some toxin or are also inducing some negative impact to the animal and are able to create physiological disorder, but also pathology. Okay, so that's also why controlling this protein strategy is something so important. Maybe one word, we are used to see a different strategy trying to decrease the content of crude protein in order to control diarrhea, or let's say pathogen development. You have on the screen one example, and you have a first feed to correct with, it's an example with 19% of crude protein. And we have two different ways of modifying and creating a safer feed. Strategy one, we decrease 1.5% the crude protein, but we keep, in this example, we keep the same quality of raw material. At the end, the non-digestible protein fraction stay the same. What is the result? Okay, we decrease the total crude protein content, but the quantity of digestible protein also decreased a lot, leading to lower performance potential, what we are not looking for. The second strategy may be a bit costly, but completely different in terms of physiological efficiency, is to decrease again the protein. Here we decrease of half point, but modifying the use and the choice in raw material. In this case, we will have a big difference in the non-digestible protein fraction. What is happening? Yes, we decrease the crude protein, but we are not decreasing the digestible protein. It's the opposite. We are even increasing the digestible protein. Meaning what? We will have less substrate for pathogen and more substrate directly for our piglet. So in this case, we are protecting the animal, but in the same time, we are providing the same amount of usable protein, again, for maintenance and growth. What's happened on the global microbiota, again, it's another way to describe this, depending on your protein content, because those proteolytic bacteria are very adaptable, fast. We call them opportunistic bacteria. As soon as the substrate is not really balanced, as soon as you have enough oxygen coming from the expression of the stress, they will develop very fastly. And in the same time, some anaerobic bacteria will disappear. And this change in the microbiota will first lead to a decrease in the diversity, but also in the metabolite production. Coming from abiosis, so bigger diversity, kind of balance in the expression of this gut microbiota, nice, let's say, gut barrier with a good mucus layer, nice tight junction, so the job is well done. And on the other hand, as soon as you are not controlling your protein, let's say, strategy, you are opening the door to dysbiosis. And this dysbiosis will create a much lower gut barrier effect, decreasing the mucus, decreasing the shape of epithelium cells, opening the tight junction, and creating inflammation. So in your strategy, again, the quality and the quantity of your protein content is something important. We have a lot of different, let's say, trials showing the impact. The one on the screen now is not done with high level of crude protein. It's really, let's say, very low, intermediate, and I should say still low quantity of crude protein offered to the animal. And you see in the ileum or in the colon, depending on this crude protein content, the Shannon index expressing a kind of diversity in this population of the gut microbiota will be different. Again, the crude protein is affecting the population of the bacteria, not only in the colon, but also in the small intestine. So one way to protect, to keep the abiosis, is to be able, from your choice, from your control, from your regularity in your diet in the protein expression, to look not for the lowest, not for the highest, but for an intermediate and control value. It's true for gut microbiota diversity, but it's also true for the gut mucosa integrity. The same trial with the same very low intermediate or low crude protein composition. You see on the left, you see that, for example, the tight junction concentration will be very different, expressing the integrity in this gut mucosa. And you see that the intermediate crude protein concentration will express a higher level both of occludin or in claudin. You will have also something visible on the shape of those epithelium cells, with also a better expression in intermediate crude protein composition. And if we want to go deeper and deeper and deeper, you have on the right of your screen some impact on biogenic amines, and some of them known as a very negative impact on the animal. And you see that, and it's kind of obvious, the highest your crude protein content, the highest is production of biogenic amines. And we cannot speak about protein and piglets without speaking about specific function. And one specific function, which is also related to the kinetic of digestion we already spoke about, is the impact on the epithelium cells development. We have some nice knowledge today on specific impact of a branched chain amino acid that will modify the development, but also the shape and the global organization of our gut mucosa. And this is something really important when you are able, close to your synthetic amino acid, if you are able in the same period of absorption to provide some specific raw material with a flash digestibility that will be able to complete an ideal profile of amino acid that will help to improve a very local valorization of those amino acids that will create a nice protection, especially again for our piglet. Something quite new but interesting also when it comes to protein is to have a word about this really specific functionality that we may have coming from a specific amino acid profile, and again, a specific kinetic of absorption of those amino acids. I want to speak about the umami effect. We have a nice discovery from Eugénie Roura showing that this umami effect, which is very different for human and swine, is for swine based on 7 to 8 amino acids that you have on the screen with threonine, proline, glutamine, aspartic acid. Those 7 amino acids are directly able, if you have them in the right quantity, but coming in a fast, I should say, flash absorption, then it will be able to regulate behavior and feed behavior of your piglet, modifying more than the palatability, modifying the appetite of your piglet, meaning better regularity and globally higher level of feed intake. So as a conclusion for this webinar on the crude protein, of course, crude protein is an essential component for metabolism and the global physiology of our animals. It will mostly affect macronutrition and physionutrition. In your job, you have to decide, and you can decide the quality of the sources, depending on the age, the maturity, or the challenge of the farm. This first step of choice is very important. It also may affect the global digestibility, modifying the anti-nutritional factors level, quality and level. You may also be able to modify the treatment, particle size, heat treatment, and you are also able to play, thanks to the choice of the sources of raw material, to modify the stomach efficiency. The second level you have to look at is amino acid profile. Okay, what is the quantity? What is the relative composition? So ideal protein. That may be something quite new, and you will see more and more important, the kinetic of absorption. How fast do those raw material will be absorbed? Digestibility is one thing. The kinetic of absorption is another one. That will drive functionality. And then coming from those choices, in the middle of other choices in your diet, you will play on gut health, inflammation level, appetite, and coming from those, the growth. So technico-economical performances. The protein formulation strategy must be adapted to, of course, the animal weight and maturity. Also, that could be adapted to the farm situation. The strategy will not be the same when you are suffering for a specific pressure from some specific disease or not. Then the time you will spend looking for specific choices, looking for specific nutrient, adjusting your cost, you will be paid back in the expression of the animal. It will help you to balance the risk between crude protein quality, and other component of your feed. And then you will be able to control maybe ingredient for the stomach efficiency, for the gut microbiota resilience, the ability to keep those microbes under control, and then control the inflammation response, what we are all looking for. Thank you very much. I hope you appreciate, and see you next time.